Did you know that the speed, time and distance topic is one of the most important and frequently tested topics in the CAT exam? In this video we will be covering some tips and tricks to ace these problems and save valuable time in the process. So, are you ready to learn how to master speed, time and distance on the CAT exam? Let's get started. It is one of the most important topics in this section as 2 to 4 questions are asked every year from this topic. Learning these tips and tricks can make a significant difference in your performance and overall score. These types of questions are known to be challenging and time-consuming, and if you're not well prepared, they can easily become a roadblock in your exam. Whether you're a beginner or an advanced CAT aspirant, this video will help you understand the underlying concepts and master the techniques required to solve these problems quickly and with confidence. We will provide you few tips and shortcut techniques to solve these questions efficiently. So, let's dive in and explore the world of speed, time, and distance problems together. Let's see what we will cover in this video. We will start with formula-based questions, then we will move to the concept of average speed. After that we will study and solve questions on relative speed and trains, then we will look through boats and streams and finally end the video with concept of races. Let's start with basic formula-based questions. You must be familiar with the formula speed equals distance upon time, or we can write it as distance equals speed into time or time equals distance upon speed. Let's look into what it signifies. If the distance is constant, then the speed and time be inversely proportional to each other, that is, as we increase the speed, the time taken to cover that distance will be less and vice versa. Let's solve few questions to know it better. Question. A man covers 80 kilometers in 20 hours. What is his speed in meters per second? As we know, speed equals distance upon time. So, here distance is 80 kilometers and time is 20 hours. So speed will be 80 kilometers upon 20 hours, which will turn out to be 4 kilometers per hour. But wait, we have been asked to tell the speed in meters per second. So there is a simple trick to convert kilometers per hour into meters per second. If we have to convert kilometers per hour into meters per second, we have to multiply it by 5 upon 18. Similarly, to convert meters per second into kilometers per hour, we have to multiply it by 18 upon 5. This is a very important trick and you should memorize it by heart as it will help you in conversion of units quickly. So in this question we have found out the value of speed to be 4 kilometers per hour. So to convert it into meters per second, we will multiply 4 by 5 upon 18, which will turn out to be 10 upon 9 meters per second. And by further dividing we get speed as 1.11 meters per second. Do remember this formula for conversion. We multiply by 5 upon 18 when we have to convert kilometers per hour into meters per second, and we multiply by 18 upon 5 when we have to convert meters per second into kilometers per hour. Let's solve another one. Question. Walking the 3 by 7 of his usual speed, Rahul reached his destination 10 minutes late. Find his usual time. At times basic logic can help you solve questions quickly. So, distance is equal to speed into time. Let's take distance as d, his usual speed as s, and usual time as t. So d will be equal to s into t. Take it as equation number 1. According to the question, when Rahul walks at 3 by 7th of his usual speed, he will reach 10 minutes late, which will give us d equals to 3s by 7 into t plus 10. Take it as equation number 2. Now equation 1 and equation 2 are equal to each other, so we will equate them, which will give us st equals to 3s by 7 into t plus 10. Eliminating s from both sides and taking 7 to left side, we get 70 equals to 3t plus 30. Solving further, we get 4t equals to 30. T will be equal to 30 by 4, giving us 15 by 2, further taking us to 7.5. Hence, usual time of Rahul is 7.5 minutes. Now the other type of questions asked are based on average speed. Average speed is basically defined as total distance upon total time. But there are certain cases where we are not given the time or the distance. Case 1. When distance is same with different speeds. If we travel a certain distance with x kilometers per hour and the same distance with y kilometers per hour, then we can write our average speed as 2xy upon x plus y kilometers per hour. Case 2. When time is same with different speeds. If we travel for a certain time with x kilometers per hour and then travel for same amount of time for y kilometers per hour, then we can simply write our average speed as x plus y upon 2 kilometers per hour. Let's solve some questions based on that. Question. While traveling from home to office, a man traveled at the speed of 125 kilometers per hour. While coming back home from office on the same path, he traveled at the speed of 75 kilometers per hour. What is the average speed of travel? Traveling from home to office and office to home, both the distances covered would be same. But he travels with different speeds. So to find average speed of the travel will be directly used from the formula we learned in case 1, which is average speed equals to 2xy divided by x plus y. Here x will be his speed from home to office, which is 125 kilometers per hour. And y will be his speed from office to home, which is 75 kilometers per hour. Putting both of them into the formula, we get average speed equals to 2 into 125 into 75 divided by 125 plus 75. Solving further, we get 2 into 125 into 75 divided by 200. We can cut 2 with 200, giving us 100 as denominator, then 25 will divide denominator by 4 and 125 by 5. Solving further, we get 375 by 4, which gets us to 93.75. Hence, his average speed of travel is 93.75 kilometers per hour. Let's see another question on average speed. Question. A driver travels for 3 hours at a speed of 20 kilometers per hour and next 3 hours at a speed of 40 kilometers per hour. Then his average speed is? Both times the driver travels in same time with different speeds. Hence, to find his average speed, we can directly use the formula we learned in the second case, where speeds are different but time taken is same in both travels. So average speed is equal to x plus y divided by 2. Here we will take x as 20 kilometers per hour and y as 40 kilometers per hour. So, his average speed will be equal to 20 plus 40 divided by 2. Adding them, we get 60 by 2, which will get us 30. Hence, the average speed of the driver is 30 kilometers per hour. Type 3 questions are based on relative speed and trains. But before going through questions, let's go through the concept. If two objects are traveling at a speed of a and b in the same direction, then their relative speed will be the difference of the speeds a minus b, where a is greater than b. If two objects are traveling at a speed of a and b in the opposite direction, then their relative speed will be the sum of both the speeds. It is written as a plus b. Next, these are some must-remember facts to keep in mind while solving questions related to trains. When a train passes a stationary object such as a man, lamp post, or sign post, the distance traveled by the train is equal to its length. When a train passes a platform or bridge, the distance traveled by the train is equal to the sum of its length and the length of the platform or bridge. Another point to be remembered. When a train passes a moving object such as a car, bicycle, or a moving man, the relative speed between the train and the object is taken into consideration based on the direction of movement of the object relative to the train. The distance traveled by the train is still equal to its length. Another point. When a train passes another train that is moving in the same or opposite direction, the relative speed between the two trains is taken into consideration based on the direction of the other train. The distance traveled by the train is equal to the sum of the lengths of both trains. Here is a question on relative speed and trains. Question. A train traveling at 90 km per hour crosses another train traveling in the same direction at 75 km per hour in 120 seconds. What is the total combined length of both the trains? Let's say the slower train A, traveling with 75 km per hour is crossed by the faster train B traveling with 90 km per hour in 120 seconds. As we have learnt, the distance traveled by the faster train to cross the slower train is the combined length of the two trains. And the speed is the relative speed between the two trains. As both the trains are moving in the same direction, the relative speed will be the difference of speeds between the two trains, which is 90 minus 75, that gives us the relative speed as 15 km per hour. And the time taken is 120 seconds. But our relative speed is in kilometers per hour. We have to convert it into meters per second. In order to do that, we will multiply the relative speed by 5 upon 18. 3 will cut denominator by 6 and 15 by 5. Hence, solving further, we get relative speed as 25 by 6 meters per second. Combined length of the two trains is the distance traveled by faster train B to cross slower train A will be equal to relative speed into time, which is 120 into 25 upon 6. 6 will divide the denominator completely and 120 by 20, hence giving us 25 into 20, which is 500. Hence, the combined length of the trains is equal to 500 meters. Now, we move to next type of questions, that is boats and streams. Let's learn about upstream and downstream speeds. Upstream speed refers to the speed of a boat or any floating object relative to the water when it is moving against the current. Downstream speed, as the name suggests, is the speed of a boat or any floating object relative to the water when it is moving in the direction of the current. The downstream speed is usually faster than the upstream speed because the boat gets a boost from the current. If speed of boat in still water is x and speed of the stream is y, then the upstream speed of boat can be written as x minus y. Similarly, downstream speed of boat can be written as x plus y. It is to be noted that speed of boat in still water x will be greater than the speed of stream y. If the upstream speed of boat is u and downstream speed of boat is d, then the speed of boat in still water can be written as d plus u by 2 and speed of stream can be written as d minus u by 2. It is to be noted that downstream speed of boat d will always be greater than upstream speed of boat u. Let's solve some question on boats and streams. Question. A man can row 45 km per hour in still water. If the speed of current is 15 km per hour and it takes 60 hours to a man to row a place and back, then how far is the place? Let x be the speed of boat in still water, which is 45 km per hour, and y be the speed of stream, which is 15 km per hour. Let the distance to the place be d, and time to go upstream be t1. As time is equal to distance upon speed, so t1 will be equal to d upon x minus y, because the relative speed moving upstream would be the difference of speeds. So t1 will be equal to d upon 45 minus 15. t1 will be equal to d upon 30. Let t to be the time to come back downstream, so t2 will be equal to d upon x plus y, as relative speed will be the addition of both the speeds. So t2 will be equal to d upon 45 plus 15, t2 will be equal to d upon 60. Total time for whole journey will be given as t1 plus t2, which is given as 60 hours. So from t1 and t2 we can write it as d upon 30 plus d upon 60 will be equal to 60. Take 60 as LCM, we get 2d plus d upon 60 equals to 60, which gives us 3d upon 60 equals 60. 3 will divide 60 by 20, then the 20 will go to other side and give us d equals to 1200. Hence, total distance is 1200 kilometers. The final type of questions are based on races. Before diving into questions, let's look at some terminologies used in races. P beats Q by X meters. This statement means that P has reached the finish line and won the race, while Q is still some distance away from the finish line, specifically X meters behind P. If the race distance is 100 meters, then P has covered the entire 100 meters while Q has only covered a distance of 100 minus X meters. P can give Q a start of T minutes. This means that P will begin T minutes after Q starts from the starting point, but both P and Q will arrive at the finishing point simultaneously. P can give Q X meters or T seconds. This statement suggests that P can provide Q with either a distance of X meters or a duration of T seconds, and from this information, you can calculate speed of Q as X by T meters per second. Let's look at a question on races. Question. In a 400-meter race, A can give B a start of 30 meters and C a start of 67 meters. What start can B give C? It means that if A is at 400 meters, B will be at 400 minus 30 meters, that is 370 meters, and C will be at 400 minus 67 meters, that is 333 meters. From here we can make when B is at 370 meters, then C will be at 333 meters. By unitary method, we can say that when B is at 1 meter, C will be at 333 upon 370 meters. So when B will be at 400 meters, then C will be at 400 into 333 upon 370, which will give us 360 meters. So 400 minus 360 equals to 40. So B can give C a start of 40 meters. And that concludes our video on tips and tricks for speed, time, and distance for CAT quantitative ability. We hope that you found the information presented useful and informative. In conclusion, mastering speed, time, and distance is a crucial skill for any CAT aspirant. It not only helps you crack one of the most challenging sections of the exam, but also gives you an edge in various other competitive exams. By practicing regularly and using simple yet effective tricks, you can significantly improve your speed and accuracy. Remember, practice makes a man perfect, and the more you practice, the more confident you will become in solving these types of problems. So, whether you're looking to brush up on your math skills, or you're preparing for an important exam like CAT, Eduref has got you covered. Sign up for our platform today and take the first step towards achieving your academic goals.